Learning target number 13, part A here. Solving this inequality, the first thing we are going to do is we're going to distribute the 2 on this side. So we will have negative 6x, which is less than 2x plus 8. Now I want to get the x's to one side. There's a couple ways you can do this, but I'm going to subtract 2x from both sides. So that means I actually have a negative 8x, which is less than 8. And I'm going to divide both sides here by negative 8. And now I need to remember, since I'm doing that, I'm going to have to flip this sign. So that becomes x is greater than negative 1. And to graph here, I know that means to the right of negative 1. So I just put on my number line a negative 1. I have a parenthesis, and I'm going to shade to the right. So in interval notation, this means that we have actually negative 1 as our starting point, not including negative 1. That's what the parenthesis means. And we're going to go to infinity. And we put a parenthesis on the infinity. Middle one here, what we want to do, and this gets a little hard to show on this, but we're going to multiply the middle by 2 to get the 2's to cancel there. They completely cancel. We're going to multiply the right by 2, and we're actually going to multiply the left by 2. That's how we do compound inequalities. So we have negative 20, which is less than or equal to negative 3x plus 1, and that's less than 10. We still got a lot of work to do to this one, so we're going to subtract 1 from each part. Make sure you're not just doing the center and the right, but each part. And I actually get negative 21 is less than or equal to negative 3x, which is less than 9. And now we've got to divide everything by the negative 3, because we want to get the x by itself in the middle. So we have 7, and now it gets tricky because, again, dividing by a negative is going to make us flip this sign. Then we have an x, and then flip that sign, we're going to have a negative 3. Now, if you see our signs are pointed in the other direction, I've got my smaller value on the right, my bigger value on the left, and I don't like looking at it like that. So I'm going to rewrite it backwards. So make sure you flip those signs if you do that. So negative 3 is less than x, which is less than or equal to 7. And this is a lot easier to graph. Now I put my negative 3 here. I put the 7 over here. And I don't need to test. I don't need to test values here because I already have an indication of my answers are between negative 3 and 7 here. So I'm just going to shade the middle here, and I look for a parenthesis on that one, and I go all the way up to 7, and I'm going to put a bracket on that one. Interval notation is getting better for most of us, so negative 3 to 7 with a bracket on the 7. That means you can include the 7, you cannot include the negative 3. All right, moving our way through this first page. We now already have, this is completely done. Let me change colors here. So this is completely done, and over here we need to solve this one. So what I've done is I've kind of put a line here so kids see that there's two things going on here. So what I'm going to do is I'm going to subtract 4 from both sides first. Minus 4, minus 4. So now I'm going to get 9, which is less than negative 3x. And it looks like on a lot of these problems, we're going to be flipping the inequality sign. So what we have here is a negative 3, and that's greater than x, because the negative 3's cancel. Flip the sign, divide by a negative. So again, I don't like looking at it like that. I like the variable on the left. It's easier for me to graph. So x is less than negative 3. All right, so look here at what I've circled in red. I've got to graph both of these individually. Well, if I look up here, x is greater than or equal to 9. The 9 is going to go on the right. It's the bigger value. Negative 3 is going to be on the left. Greater than or equal to 9 would be a bracket, and bigger than 9. Less than negative 3 would be a parenthesis, and anything smaller than negative 3. So interval notation here, the furthest value left would be as far as we can go left. We work left to right for interval notation. That's going to be negative infinity. And we go all the way up to negative 3, parenthesis, because we can't include that. And then we say or, which is the special symbol, the union symbol. And then we say bracket 9 forever to the right, which would be infinity. Okay, moving to the next one here until we get to the back side. I have fractions. So my first step is going to be to find the common denominator. So I have a 1 on this, and I have a 1 there and a 7. So pretty easily we can see The common denominator here is going to be 7. All right, so be careful. I'm actually going to show my work a little bit differently here. I'm going to say 7 over 1, because some kids are still struggling with this, times 7 over 1. That's what we did the first term here. Then we actually have 3 over 7x times 7 over 1. And then we have greater than or equal to 2 over 1 times 7 over 1. I'm showing all of this work because kids are still getting a little confused by what's going on up here. So this is essentially just multiplying by 7 to every term. So 7 times 7 is really just 49. And then here the 7s are going to cancel, leaving 1s. So we have just minus 3x. We have a greater than or equal to the number 14. We don't have to flip the sign because we multiplied by a positive 7. All right, so subtracting 49 from both sides is what I would want to do next. And I'm going to get negative 3x greater than or equal to 14 minus 49, which is going to be a negative 35. Then I want to divide by negative 3. I'm running out of room here, but I need to switch that sign. Again, divided by a negative. Seems like we're practicing that a lot on this worksheet. So what we have is actually a positive 35 thirds. Okay, or you could change it to an improper, or sorry, to a mixed number or to a decimal. It doesn't matter. That's fine. So on our number line here, we're going to have 35 thirds, and we're going to shade to the left of it with a bracket, which means we include that. So the interval notation here again would be forever left, negative infinity, all the way up to 35 thirds with a bracket. All right, I'm going to stop this video so that it doesn't get too large, and you can check the other video for the absolute values. Okay, notice no splitting or anything in this one. The absolute values are the trickier ones, and that's page 2 to be continued.